And so now we can talk about a couple of theorems that guarantee for you when Fourier series converge nicely. So the first one is just that if f is piecewise smooth, notice PW here is piecewise, not pointwise. So if f is smooth except at finitely many points, and it's 2L periodic, then its Fourier series is going to converge to the average value of its upper and lower limit at any particular point. So in particular, if it's continuous at some point x, then the upper limit and the lower limit are the same, and so then the Fourier series for f just converges pointwise to that value. So that's wherever f is continuous. If f is C1, so a C1 function, that means that f prime, the first derivative, is continuous. So if f prime is continuous, then its Fourier series necessarily converges uniformly to f. And it can be shown, it's actually, it follows from the proof of this theorem, that if you've got a continuous function, so if f is continuous on the interval from minus L to L, and the sum of the absolute values of the Fourier coefficients converges, so if the Fourier convergents are absolutely summable, or absolutely convergent, then it will converge uniformly. We saw before that term-by-term differentiation is not always justified. It turns out it's not justified specifically when the periodic extension of f has a jump discontinuity. And so this is why we saw that differentiating the Fourier series for x didn't work. We couldn't do term-by-term differentiation. And that's because even though x is continuous, its periodic extension is not continuous. It has a jump discontinuity, and that's what's messing up the term-by-term differentiation. If f prime is piecewise smooth, however, and if its Fourier series is continuous, then it can be differentiated term by term. And it's also worth noting that you can do term-by-term integration always. So the Fourier series for f can always be integrated term by term to obtain a series that converges pointwise. The only sort of caveat or whatever with this result here is that the resulting series might not be a Fourier series. And just think about that. If there's a constant term and you integrate, then you're going to get a linear term x. So that's not part of a Fourier series.